Danny, you got that new shell working?
I'm working on it. I think I got it.
Looks like that additive really came out good.
Yeah, we're trying to create a sponge here. Put a lot of air bubbles in it and make oil absorption out of a bowling ball. And I think that new additive is definitely making it foam.
So the oil absorption is going to be faster, create more friction?
Yeah, what we do in a bowling ball, we want to get friction. One way, the ball's rolling down a lane, picking up oil on the surface of the ball. So we can create a sponge and make the oil soak into the shell. We can get more friction because we get the oil off the shell. Here's our new Brake S75 ball. What we do for oil absorption, I'll just show you, do a little demo here. Put 1 drop of oil. Move it around over about a little 2-inch square area. We'll just mark it there. Now, good shell, that oil is going to soak into the shell in a short period of time. Last year, the USBC did a ball motion study. And they did lots of different tests on all different people's products, and they determined that surface roughness, friction, and oil absorption are key ingredients to making a ball hook. Well, everybody knows about roughness. You sand the ball rougher, to make it hook more in oil. But they basically sanded all the balls the same and found that some balls are rougher. The chemists at BASF have kind of predetermined that themselves at Columbia when I work with them. They do a test, it's called atomic force microscope, where they actually go across the surface with a little probe, and it moves up and down depending on the roughness of the surface. It can measure depressions in the surface from a microscopic point of view. And then what they're trying to do is make a shell that basically has wormholes through it, like our junk over here. Create wormholes so the oil can soak in. It's starting to go there. If the wormholes create a rougher surface and also remove the oil from the surface of the ball, we have more friction over here than if we rub in the oil over here. So if we get that oil off the surface, we're going to create more friction. And our new Brake S75 ball has the fastest oil absorption of any of our shells. The other thing we're doing at 900 Global, I always thought it was kind of confusing what all the manufacturers do in their ball names. This shell's called this shell's this shell's this. It's hard to figure out which one is the most aggressive to the least aggressive. So we try to simplify it. Our shells are called S for shell, S10, 20, 30, 40, 50. The bigger the number, the stronger the shell. Smaller number, the less the shell hooks. So every shell we come out with will be called an S10, an S15. This one started with the S70 shell, then we put an additive in it that made it more aggressive, and then we called this one the S75. You don't have to know all the information other than S75 hooks more than S70. And that's our terminology for shells that hopefully simplifies it for the pro shops and the bowlers. And looking at the oil, it's pretty much all gone in our spot, and that's our goal, to eliminate the oil to increase friction.
Okay, Danny, I just got out of Nick's office. He's got the core in motion. Looks like you've got the cover stock. Great things here at 900 Global. It looks like we don't confuse the customers anymore. I'm just going to tell them on a shell straightness chart how strong that shell really is, from, you said S0 to S100, I guess. This being S75, sounds like it's pretty strong compared to what else we have in the line. I see this ball's got some pearl in it. Why don't we tell them what the pearl actually does to the motion of the ball going down the lane?
Okay, this ball actually, the black is solid, and the silver color has an additive in it that makes it look pearl. All really pretty balls have this pearlescent added to it. It's a material that gives you depth as far as seeing into it, makes it look real pretty, but it actually affects the performance of the ball. Pearls have a tendency to slide more in the oil and then flip harder on the back end. So they're not the greatest heavy oil ball, but we got around it for this ball because we put that other additive in there that helps the ball soak up oil. But pearls normally just help the ball slide further and flip harder on the back end of the lane.
So the other additive is a family secret that you've had for many years, huh?
We've been holding this one back, and we're putting it into this ball for the first time.
Sounds pretty cool. So the pearl actually reduces the friction in oil, which pushes it down the lane for us, right?
There you go, yeah. I've always said that the shell basically determines the friction with the lane, how hard it grabs, whether it slides or grabs real good. And the core really affects the rotation on the ball. If you put the weight near the middle of the ball, it's easier to spin off your hand. You get more revs on the ball, which helps it hook. Move the weight to the outside, makes the ball slide further and flip further down the lane. So the core is affecting rotation, the shell's affecting the grab to the lane surface or to the oil on the lane surface.
And a particle does actually does the reverse. You'll start it up earlier?
Yeah, particles are just what they say. They're particles that little solid particles that you put in the shell, and you can think of them like on a snow tire. If you were to add the metal studs, well, the particles are little particles that stick out of the surface, and in oil there's only a couple thousandths of an inch of oil, so a little particle that sticks out of the surface can bite through the oil and give you more friction in oil. And we have a whole series of different size particles. The bigger the particle, the more it sticks out, the more it grabs in the oil, more friction in oil. So particles add to the friction, pearlescents take away from the friction in the oil.
I tell you what, I am so glad that we use shell numbers to measure the strength, because I don't want to keep up with all that stuff.
It can be complicated. We're trying to make it simple.